Welcome to our journey through the cosmos. You know, the universe is a pretty big place. Like, really, really big. And it's full of mysteries that make us question everything we thought we knew about reality. Today, we're diving into some mind-boggling facts about time and space that will make you question reality. Get ready to have your mind blown wide open. Ever heard of Einstein's theory of relativity? It's not just some abstract idea. It has real-world implications. One of the most mind-bending is time dilation. Imagine this. You're on a spaceship cruising at a significant fraction of the speed of light. Meanwhile, your friend Bob is back on Earth, watching you through a really powerful telescope. Here's the kicker. Time actually moves slower for you than it does for Bob. This isn't science fiction, it's physics. The faster you move through space, the slower you move through time. It's all relative. Now, before you start planning your interstellar trip to exploit this phenomenon, remember the effect is minuscule at everyday speeds. We're talking about speeds approaching the speed of light for noticeable time dilation. But it does make you think, doesn't it? Time isn't the constant we perceive it to be. It's all relative, my friends. Let's talk about size. When we say the universe is big, we're not talking about the distance from New York to Los Angeles, or even from the Earth to the Sun. We're talking about distances so vast they make your head spin. The observable universe, that's the part we can see from Earth, is estimated to be about 93 billion light-years in diameter. Let that sink in for a second. 93 billion light-years. To put that into perspective, 1 light-year is the distance light travels in a year, about 5.88 trillion miles. So 93 billion light-years is, well, it's a number so big it's practically meaningless to the human brain. And here's the kicker. That's just the observable universe. Who knows what lies beyond the cosmic horizon, hidden from our view? The sheer scale of the cosmos is enough to make you feel incredibly small, but it also fills you with a sense of awe and wonder. Black holes are among the most fascinating and mysterious objects in the universe. They're regions of space-time where gravity is so strong that nothing, not even light, can escape. Imagine a giant cosmic vacuum cleaner, sucking up everything in its path. That's kind of what a black hole is like. They form when massive stars collapse at the end of their lives, squeezing all their matter into an incredibly small and dense point called a singularity. What happens inside a black hole? We don't know for sure. Our current understanding of physics breaks down at the singularity. Time and space as we know them cease to exist. Some theories suggest that black holes could be portals to other universes or even time travel devices. But for now, they remain one of the biggest unsolved mysteries in the cosmos. Chapter 4. The Cosmic Speed Limit. Why nothing can outrace light. We all know that light travels incredibly fast, approximately 299,792,458 meters per second in a vacuum, to be precise. But here's the thing, nothing in the universe can travel faster than light. It's the ultimate cosmic speed limit. Think of it this way, imagine throwing a baseball. The harder you throw it, the faster it goes, right? Now imagine throwing it with all your might, and then somehow throwing it even harder. Could you keep making it go faster and faster? According to Einstein's theory of special relativity, the answer is no. As an object approaches the speed of light, its mass increases infinitely, which means it would require an infinite amount of energy to accelerate it to the speed of light. The speed of light isn't just a speed limit, it's woven into the very fabric of space-time. It's a fundamental constant that governs how the universe works. Chapter 5. Parallel universes. Are we living in a multiverse? Here's a mind-bending thought. What if our universe isn't the only one? What if there are countless other universes out there, each with its own unique laws of physics, its own history, and maybe even its own versions of us? The idea of parallel universes, or the multiverse, has been around for centuries, but it's gained traction in recent years thanks to advances in theoretical physics, particularly in fields like string theory and quantum mechanics. Some theories suggest that our universe is just one bubble in a vast cosmic foam of universes, constantly expanding and colliding with each other. Others propose that parallel universes exist in different dimensions, right alongside our own, but invisible to us. While the multiverse remains a purely theoretical concept, the possibility that we're just one of an infinite number of universes is both exhilarating and terrifying. Chapter 6. The Big Bang. The beginning of everything. Or was it? Let's rewind the cosmic clock all the way back to the beginning, to the Big Bang. About 13.8 billion years ago, our universe was born from an incredibly hot, dense state. Imagine all the matter and energy in the universe crammed into a space smaller than an atom. Then suddenly, it exploded, expanding outward at an incredible rate. As the universe expanded, it cooled, allowing particles to form, then atoms, stars, galaxies, and eventually planets like Earth. But what caused the Big Bang? What existed before it? These are some of the biggest questions in cosmology, and we're still searching for answers. The Big Bang Theory is the best explanation we have for the origin of the universe, but it's not the whole story. There's still so much we don't know about the very first moments of existence. Chapter 7. Space-time. It's not just a big empty box. We often think of space and time as separate entities, but they're actually intimately connected, forming a four-dimensional fabric called space-time. Imagine a trampoline. If you place a bowling ball in the center, it will create a dip in the fabric. That's similar to how massive objects like stars and planets warp the fabric of space-time. This warping of space-time is what we experience as gravity. Objects aren't really attracted to each other. They're simply following the curves in space-time created by massive objects. The more massive an object, the more it warps space-time, and the stronger its gravitational pull. It's a mind-bending concept, but it's essential to understanding how the universe works at its most fundamental level. What if we could fold space-time like a piece of paper and create a shortcut between two distant points in the universe? That's the basic idea behind wormholes, theoretical tunnels that connect different regions of space-time. Imagine stepping into a wormhole in our solar system and emerging near a star thousands of light years away. It would be like taking a cosmic shortcut, bypassing the vast distances of space. While wormholes are theoretically possible according to Einstein's theory of general relativity, they remain purely hypothetical. We've never actually observed one, and creating one would require unimaginable amounts of energy. But the possibility of wormholes, however remote, continues to capture our imaginations, fueling our dreams of interstellar travel and exploring the far reaches of the cosmos. The universe isn't static. It's constantly expanding. It's like a balloon being inflated, with galaxies moving away from each other like dots on the surface. This expansion was first discovered in the 1920s by astronomer Edwin Hubble, who observed that galaxies farther away from us are moving away faster than those closer to us. The expansion of the universe has profound implications for its fate. Will it continue expanding forever, or will it eventually slow down and collapse in on itself in a big crunch? The answer depends on the amount of matter and energy in the universe, and whether the expansion is accelerating or decelerating. Cosmologists are still trying to figure that out. Given the vastness of the universe and the billions of stars and planets out there, it seems statistically improbable that we're alone in the cosmos. So, where is everybody? This is the essence of the Fermi paradox, named after physicist Enrico Fermi, who famously posed the question, where is everybody? There are many possible explanations for the paradox, ranging from the possibility that intelligent life is extremely rare to the idea that advanced civilizations might be deliberately hiding from us. Perhaps we're the first intelligent civilization to emerge in our corner of the universe. Or maybe, just maybe, we're looking for the wrong signs of extraterrestrial life. The Fermi paradox remains one of the most intriguing and thought-provoking mysteries in science, reminding us that for all our knowledge, we're still just beginning to scratch the surface of what's out there. Thanks for joining us on this incredible journey through time and space. We've explored some of the most mind-boggling concepts in the universe, from time dilation to black holes to the possibility of parallel universes. But remember, this is just the beginning. There's so much more to discover out there. Don't forget to like, subscribe, and hit the bell icon for more fascinating content. Keep looking up, and never stop questioning the nature of reality itself.